in order to simplify number 1, you're just going to multiply the numbers right here. So 3 times 2 would be 6, and then when we're multiplying exponents, we look to see if they have like bases, and then we're going to add the exponents. So I have 2 here and 3 here. So that gives me a total of 5. So final answer is 6x to the 5th. Number 2 is an example of power to a power. So we're going to apply that square. So 3 squared is 9. And the rule here is that you multiply your exponents. So this is going to be y to the 5 times 2, the 10th power. And z gets applied to this imaginary 1 right here. So that turns into the 2nd power. What I would do first on number 3 is to divide 10 and 2. So 2 goes into 10 5 times, 2 goes into 2 1 time. And if I'm dividing, I need to look at my exponents and I need to subtract them. So I have 7 minus 4, which gives me 3. So that would be a to the 3. So my answer would be 5a cubed. Number 4 is a multiplication problem. So I'm going to move this negative exponent down to the bottom. So I'm just going to say negative 9 over x to the positive 2 times 1 over 3. Keep that there. So we're just going to multiply through the top. That turns into negative 9 x to the 5th over 3x squared. So we're going to reduce the fraction of 9/3. So 3 goes into 9 negative 3 times, and it goes into itself once. And my rules for dividing exponents, I'm going to subtract the exponent. So I'm really looking at 5 minus 2, which is 3. And because it's a positive number, it can stay at the top. So my answer would be negative 3x cubed. The first thing that I would do on this one, notice that I have a negative exponent, and I don't like those. So I'm going to take the reciprocal of the whole thing. So I'm going to put 4a on the bottom, and I'm going to put 2a to the negative 1, and then this whole thing will now be squared to the positive 2. And I can go ahead and reduce this right now if you want to, or you can do it at the end, doesn't matter. I'm going to do it right now though. So I'm going to reduce the fraction of 2 over 4 to 1 over 2. And I'm going to square that. And now I'm going to actually apply that. So I'm going to say 1 squared is 1. And remember, power to a power, I'm going to multiply. So I'm going to have negative 2a's. And that 2 also applies to the bottom as well. So that's going to be 2 squared is 4. And a, remember, I have an imaginary 1 there. So I'm going to multiply my exponent. So I'm going to have a squared. So I see I'm dividing, so I'm going to subtract my exponent. So right here I have a negative 2, and I'm going to minus a positive 2. And if I keep flip change, that turns into a negative 4. So now I'm looking at 1a to the negative 4 over 4. And the last thing I'm going to do is deal with the negative exponent by moving it down to the bottom. So I still have 1 over 4, but I'm going to kick that a to the negative 4 down to the bottom until it becomes positive. So now my answer would be 1 over 4a to the 4th. Number 6, you're going to multiply through the top and the bottom. So I'm going to start here and say 2 times 9 is 18. And x squared times x, remember I have an imaginary 1 there, so I really have x cubed And don't forget that, so now I have y cubed as well. And let's look at the bottom. I've got 3x y to the 4th. Next thing we're going to do is reduce this fraction of 18 over 3. So 3 goes into 18 6 times, and 3 goes into itself once. And let's look at my exponents. I'm dividing them, so I'm actually going to subtract the exponents. And there's a 1 here, so 3 minus 1 would leave me with x squared. And my y's, I have a y to the negative 1, because I have 3 minus 4. So 3 minus 4 would give me negative 1. And that's still not a good answer because my y to the negative 1 has a negative exponent. So we're going to kick that down to the bottom, making it positive. So 6x squared, y goes down to the bottom.